I'm in a person of Solomon Bright, and I'll be taking you through thermodynamics. And this is a typical example from it, in which I'm going to solve it with you and go through. At the end of it, we should be able to solve this particular question. From the first video, we were able to see that we solved for the work done, in which the work was the mass integral of PDV. So that means that this was a change, right? So maybe, for instance, we are having an initial volume, then final what? Final volume over here, because this one can be the same as the W is equal to the mass multiplied by the what? The P times change in volume, because all these things is dealing with the change in volume. So this is what we did. Now, from this here, we can also have another way of solving this particular question by using this formula too as well. So your work done is equal to the final pressure here times your final volume here minus P1 V1 all over 1 minus N. So this is the formula that we are going to use to solve this particular question. You can either choose it into two folds. You can decide to choose using this formula by the integral function over here, or you can choose to use this formula too as well. So let's solve this particular question together, and hope all of you get your calculator with you so that you try as much as possible to solve this particular problem. Okay, so let's start. Now it says that a fluid at 10 bar is enclosed in a cylinder behind a piston, the initial volume being 0.05 meters. Calculate the work done by the fluid when it expands reversibly according to a law PV cube is equal to C to a final volume of 0.06 meter cube. Now, first of all, get to know that for this particular question, for instance, let me use this as an example. So we can have a cylinder here with a piston, all right? So let's see something over here before we start with the question. So for instance, this is how the piston is. So initially, this is what the cylinder together with the piston was. So this was the initial volume. So the initial volume was V1 here. Then based on the pressure being given, that means we are also having our pressure P1 here. Then for some time it's expand. So that means that at this point over here, the whole of this piston has now moved to the what? To the top. So we are having, so for instance, this our initial volume here V1. Then we are having our final what volume here as what? As our V2. Dealing with what? Pressure 2 here P2. So this is how the question is. So at first it was here, then now it has now moved to this side. So that means that work has now been done, right, by the system on the surrounding. Okay, so we are supposed to solve for these two particular questions, and I'll be using this particular what formula. You can choose to use this, or you can choose to use this particular formula over here. So you can see we have our P2 V2 here, P1 what our V1 2 here too. Our final pressure, if you look at it from the data being given, we were not given, right? But we know that it said a fluid at 10 bar, so that is the initial what? Initial pressure. So that is 10 bar. Then we also have the initial volume 2 here, which is 0.05 meters. So this is the volume 2 that was given. Then lastly, we're given the final what? Final volume, which was 0.06 meter cube per what? Meter cube. Now, don't forget that anytime you are given this question or particular question, get to know that the mass flow rate here multiplied by the specific volume here, all right, is equal to the main volume. So in the question, you see that there was no mass being given. And this question today didn't mention any specific volume. They mentioned the main volume. So that's what we are going to use over here. So from the formula two, we're going to use it at this point here. So that's the whole of it. So let's write our data down and now solve it together. Okay, so let's start writing our data down. So first of all, you're going to write our initial pressure, which is what? Which is P1, right? So we have our P1 here, which is equal to 10 times 10 raised to the power what? 5. So that's our what? That P1 here, alright, which is 10 times 10 to the power 5. That is the bar. So the bar means that 10 to the power 5, we have the initial volume to be V1, which is equal to 0.05 meters. Then our final volume was what? So that's our V2, which is 0.06. Okay, meter cube. Don't forget this one is meter cube. And finally, were you given our final pressure? No, wasn't given. So you're going to use this formula over here to solve the question as follows. So the whole of this one here, we're going to use it. We're going to use this one to solve it. So let's start. So now my work is equal to my P2 V2 minus V1 on 1 minus n. Now let me divide this one into 2 so that I can make it simple. So first of all, I want to use this. But I know my P2, I know my V2, I know my P1, I know my V1. But looking at the P2 here, we weren't given. Then now we're given 1 minus n. And from the question, we're given a law of what? PV cube is equal to C. So that means that at this point over here, we are having the PV exponent n is equal to what? C. And now n is equal to what? Is equal to 3. Because whatever is here is what? Is what? And was given from this. So that is the PV3. So it's equal to, so our n is equal to 3. So now we know all the data being given, but the parameters from P2, we don't know the value of it. So we just calculate for it. So you can also say that since we have the law that we have the PVQ is equal to C, that means we can have P1 V1Q is equal to P2 V2 what Q over here is equal to what? Is equal to C. Now I know my P1, I know my V1. Do I know my P2? No. So that means I need my look for my P2. So I'm going to have my P2, alright, my V2 or Q or exponent Q is equal to P1, alright, V1 or Q. Then I divide both of them by what? By V2 or Q. I'm looking for my P2. Then V2 exponent Q here. So this one here, or then you now have V2 to be equal to. So you can even factorize this one by getting the whole of V1 exponent 3 on V2, alright, exponent what? Exponent 3. Let me do it well. Okay, so exponent 3 then times P1. So in all, we can say we have our P2 to be equal to, so you can have V1 on V2 exponent 3 times V1. So let's put the values into it. So let me try and divide this one to 2. So we are now going to have P. Okay, so we're going to have our P2 to be equal to, so from this, you know our V1. So our V1 was what? Was 0.05 on 0. What's our V2? So our V2 was 0.06, right? They have 0.06. Alright, exponent 3 multiply by what's the P1. So P1 was giving you 10 bar. We have the 10 over here times 10 exponent 5. So I have my P2 to be equal to so 5.787. Then we have the what times 10 raised to the power of 5. So from equation 1 here, we said our work, okay, is equal to, so P2 V2 minus P1 V1 all over what? 1 minus n. So we know that now we know our P2, right? So which is 5.87 times 10 to the power of 5 here. So just take bring the whole of these 5.87, then we use the P1 2, we substitute them into the what? Into the formula. So that is all. So let's see. So what's our P2? So you know that our P2 is 5.87. Then we can try to factorize the whole of the bar from it times the what? The V22 as well. V2 was 0.06 minus the P1, which is our P12, which is, what's our P1? Our P1 was 10 here, multiplied by the V1, which is 0.05 here, on what? On 1 minus, what's our n here? N was 3 here. Then we bring this one here. Then we add times 10 with the power of 5, because we have factorized the 10 with the power of 5 from it. So we're going to have our W, that is our work done, to be equal to 7639, alright, Newton meter, which is approximately to 7, 6, alright, 4, 0 Newton meter. Thank you.